All right, so this is problem number 37 out of chapter 2.2, page 113 in the book. For this problem, they asked us to find the zeros algebraically. Another term for zeros would be the x-intercepts. Okay? And the reason it's called zeros is along the x-axis. Okay? That's when we know that y is in fact equal to 0. Or in more general terms, the output is equal to 0. So looking at the problem here, I can see that my output is none other than f of x. So what I'm going to do as a first step is I'm going to set that equal to 0. Rewrite the rest of my function. Okay. So from there, you should see that this is the type of equation that you've seen many times before. The first step is always to look for a greatest common factor. I see that all of these possess at least one x, so I can factor an x out of this. So I get x times x to the fourth plus x squared minus 6. Now, from here, you actually could use the quadratic formula to try to find the roots of this, but I'm going to go ahead and see if it's factorable. So my up top, I'm going to put 1 times negative 6, and I'm looking for two numbers that multiply to equal negative 6 and add to equal positive 1. And if you kind of mess around with those, you can see that that would be 3 and negative 2. Okay, so when I factor these out, I'm going to go ahead and rewrite everything else. I get x times, don't forget about the x there, x times x squared, okay, plus 3 times x squared minus 2. Okay? And then just double checking, if I do first, I get x squared times x squared is x to the fourth. Then I get x squared times negative 2, so negative 2x squared plus 3x squared would give me x squared. And then 6 times 2 is negative 6. So I know that this I can get back from my factors to my original equation here. Now with the zero product property, I'm going to take each individual factor and set it equal to 0. So I get that my roots are x equals 0, x squared plus 3 equals 0, and x squared minus 2 equals 0. We go about solving these, and we get, I subtract 3 from both sides of this, and I get x squared is equal to negative 3. Okay. I take the square root of both sides, okay, and I see that in fact I come into an issue that this particular piece is not a solution, or not a real solution if we want to be more specific. So I'm done with this piece. I move over here, and I can feel pretty confident that this is going to end up working. I get x squared is equal to 2. X squared is equal to 2. Take the square root of both sides, keeping in mind here that I get that x is equal to not just 2, or the square root of 2, but plus or minus the square root of 2. Okay. And I'll go ahead and move up here a little bit so I have a little bit of additional space. So we can write our solution in set notation that x is equal to, the zeros would be 0, this one here, and then square root of 2 and negative square root of 2. And if I wanted to write those as points, I would set up my 3 points. Keeping in mind that my y term for each one of these will be 0. And then my x for the first one is 0. Here it's square root of 2. And here it's negative square root of 2. Depending on how they're asking for the answers, this would probably be the preferable method unless they're simply asking for the x values. All right. Now, it did say in the problem as well to go ahead and graph the equation. So if we plug in the original equation to check our answers here, I'd put in x to the 5th power plus x to the third power minus 6x. Oops, I did that wrong. X to the fifth power plus x to the third power minus 6x. Graph it. Okay, and taking a look at my graph here, I can see that as it's supposed to, okay, I have an x-intercept right over here at negative square root 2. It's a little above 1, which if you plug negative square root 2 in, you'll see that it's a little above 1 there. At 0, and right over here at square root 2. That concludes the explanation of this particular problem, and you probably couldn't see it.